Good afternoon. Myself Rajesh RK. I'm a lecturer in Department of Computing Information Science, Utah Stinas. I'm here to present my research paper titled Cloud Enabled Digital Transformation, a systematic review and integrated framework for scalability, DevOps, and IoT. Paper ID is 21. So here first thing we have introduction. So let me make it full slide. So in this paper, we are not just summarizing the existing research. So we are analyzing how the cloud computing is changing the software development process. So in this page, we are discussing about cloud computing, DevOps, and IoT in basics. Okay. So cloud computing implements on-demand access and pay per usage model for storage, computing, and applications. So whenever you want to use the storage or computing or applications whenever you want, wherever you want, then you have to pay as per the usage. You can go for cloud computing. So it provides flexibility, it is scalable and cost efficient. Okay, and it supports IaaS, infrastructure as a service, platform as a service, and software as a service. And next is DevOps. It's a modern approach for software development. It collaborates development and operations together. That's why DevOps. Why we are collaborating? To deliver the applications faster and reliable. Then using IoT with cloud computing. So IoT, Internet of Things. So anything can be connected to internet. So we have IoT sensors. They will be reading the data from physical environment. Then the controller will be processing data. Now, when you are integrating IoT and cloud computing, you are using SaaS model for uploading the data and visualize the data easily. Okay. So digital transformation is when businesses use all the above technologies to change how they operate, how they deliver the value to customers, and how they compete in the network. This is the introduction part. What is the motivation behind this research? So actually, this is a assignment given in my research methodology. Okay. So here, why I choose this topic is so currently we are using cloud computing, DevOps, and IoT independently. For implementing digital transformation, we need to develop a framework that will combine or integrate all the above technologies like cloud computing, DevOps, and IoT to a single platform. Okay, that's why the motivation for the research and the gap we found is security of data. When you are integrating all these things, what about the security of data and interoperability that will operate in different platform or not? Okay, objectives: how the cloud computing helped the software organizations to achieve digital transformation by analyzing the journal articles published between 2017 to 24. And we study the service models IaaS, PaaS, SaaS, and we study about DevOps and IoT. And based on that, we propose an integrated framework which will combine all these technologies. That's the objective. Then we discuss about cloud service model. We have IaaS, infrastructure as a service. There we discuss about virtual server, like virtual machines. Okay, with operating system, RAM, processor for cost reduction. PaaS, platform as a service. Here we will focus on developing platforms, operating systems, then application program interface, etc. SaaS, software as a service. There we are focusing on the end user application softwares like Google Calendar or something. Okay. Then what about DevOps in cloud? They focus on collaboration, automation, and continuous improvement across software lifecycle. As we discussed in the earlier part, DevOps means development and operations. Okay. So here we have version control. There we have we are going to discuss GitHub or GitLab. So what they will do, they're the foundation tool for managing code changes, branching, and collaboration. So you can have only one copy, single copy of file stored on the GitHub. Okay, if you are going to change that one now, it will be having the updated version. So I'll show you my GitHub account and see how it is be done. Okay, go to the GitHub here. So sign in. This is my GitHub where I have uploaded my different machine learning and IoT projects here. Okay, few projects. So when I go to this Rajesh Kala ML machine learning heartbeat program, I have a copy here. Okay, the program is here. So whenever you are changing this, no, the version also will change. And this version control, yani this is It will show only the final, the law, which one updated version. Okay, whatever changes you make, it will be showing the final version only. That's what version control. Then we have CI/CD, continuous integration deployment. So that means automate the process of building, testing, and deploying the code. So the process of building the code, testing the code, and deploying the code, all things are done automatic. Okay, automated. And tools like Jenkins, GitLab, CI/CD, GitHub Actions, they help the developers automatically run these steps, making the software development faster and more reliable. That's the things coming under DevOps. What is the advantage of DevOps? We can have collaboration, automation, continuous improvement across software lifecycle. We can make version control, only one copy file stored in the GitHub. Then we can have faster, reliable software generation development by using CI/CD. Then we have IoT integration. So how do we integrate IoT in our paper? So IoT means Internet of Things. I told you we have different sensors to collect data, and the data collected by sensors will be processed by Raspberry Pi, and the updated data will be uploaded to cloud platform like ThinkSpeak for visualization, data analytics. Okay. Then we have methodology. So what is the methodology here? I was I was doing a systematic literature review. Okay, by reviewing the recent literature, then building analytical framework, synthesize data, validates my findings to evaluate cloud-enabled digital transformation with DevOps and IoT. Okay, and this process has four phases. One is literature collection screening. So I collect literature and screen it like peer-reviewed studies. I done took the papers from 2017 24. So sources are like I took the paper from sources like IEEE Explore, Science Direct, ResearchGate, Google Scholar, and I used the keywords, Boolean searches like cloud computing and digital transformation, IaaS, PaaS or SaaS, then cloud and DevOps, and cloud and IoT implementation. Okay, these are the keywords I use and screen the papers based on that. Analytical framework development. So I made based on this I made a analysis framework focusing on cloud service models like IaaS, PaaS, and SaaS, and role of DevOps and digital transformation. Okay. Then data extraction synthesis. So based on that, I extract some information. So extraction is based on key information like objectives, methods, results, benefits, limitations from each paper, each study, and I categorize them. Then comparative analysis and validation. I will whatever findings I got from the paper, no, I will compare them, then evaluate the benefits like scalability, cost optimization, DevOps efficiency, IoT integration. Based on these things, I'll validate which one is the best one like that. Okay, which one gives more effective outputs. Okay, that one. Then this is my proposed framework. I have four layers: infrastructure layer, then DevOps layer, development layer, then application layer, then governance layer. Okay. So infrastructure layer has IoT sensors which collect the data, and the sensors or the device are connected by a network. Okay, and they have a gateway router as a part of edge device or edge computing. The data will be processed inside the router itself or the gateway device and stored in the local storage. But for further processing and data analysis, you can upload that to cloud platform called ThinkSpeak. That's what in the first layer. Development layer, we are going to build the software and manage it. For that, we use CI/CD, continuous integration, continuous development, delivery pipeline, which is an automated workflow which streamline the development of software. So by tracking the changes in code using Git version control process, test the code, automatically deploy the application using tools like Jenkins and Docker. So automatic deployment, testing, uh, verification or version control, everything done in this development layer. Application layer, the user experiencing the user which an IoT application, whatever application you have developed, no, the user will be interacting with it. So that time, example like smart home and smart agriculture, user will be interacting with it, and the data given by this applications will be analyzed and predicted using data analysis and machine learning applications like agriculture crop selection. So we'll give some inputs, and based on the input, we'll have a model, and the model will predict the output, which crop is best for that situation or condition for sensors values. Okay, and this data can be monitored using web or mobile applications. Okay, so you'll be getting the output in web application or mobile application, or maybe application program interface. Then we'll have a ThinkSpeak based platforms where you can see the outputs. Okay, last layer is governance layer. Governance layer. So that acts a security manager, ensures everything runs safely and in the right way. Okay. It has a security and compliance layer. So it has set of rules to maintain the privacy of data, and it has monitoring performance system also. Okay. Benefits of our model: cost efficiency, scalability. See, first one, cost efficiency. The cloud computing reduces the cost of buying hardware. Okay, if you have cloud account, it can get IaaS, infrastructure, platform, application, anything from cloud. Okay, no need to buy the hardware for that. Then it provides key services for free or through subscription. Sometimes no, the service will be given free of cost, or you have to give the subscription amount only. Okay, so the organizations can reduce the cost of implementation. Scalability, we can utilize the resources. We can do the scalability via vertically or horizontally. Vertically, the system increase the processor and RAM of current machine. That is vertical scalable scalability. Horizontal scalability means deploy the applications or many machines geographically dispersed through the browser, requiring little machine resources. Okay. So we have vertical and horizontal scalability. That's what mentioned here. Vertical means increase the processor and RAM of current machine. Horizontal means deploy the application over many machines across the network. Okay. Again, another benefit is DevOps integration and accelerated deployment. So as we discussed in the beginning, DevOps means development and operational team work together. Why they're working together? To make the software development process faster, improve automation, minimize human errors, speed up release cycle. The product will be released. The versions, no, different versions are released faster. Implementation of CI/CD pipelines increase the speed of software delivery. The quality of code produced. Okay, and next one, reduced maintenance burden. So we have the cloud computing providers. No, the maintenance of hardware and software will be handled by the cloud computing provider. Okay, so the company can focus on the core competencies, and they don't want to focus about whether the hardware or software is failed or not. They'll that manage maintenance will be done by the cloud providers. Then enhance security and disaster recovery. So here we have encryption protocols for encrypting the data for security. Then identity and access management, like access control, who will access what data, what time, like that. Intrusion detection system, so system to detect any intrude into the network or the system. And geographically dispersed backup architecture. So instead of storing the data centralized in a particular location and it may fail, what we do, we geographically displace or disperse the data into different backups. So we can these are used for recover from the disasters. Okay, if you have only one copy and that has gone, means we cannot recover. That's why we keep copies in different locations so that we can easily recover from the disaster. Okay. Then another benefit is IoT and real-time analytics capabilities. So the IoT sensors which collect the data can be analyzed in real time by using cloud platform, which is coming under SaaS service of cloud. Okay, there we can upload the sensor data, visualize and analyze data. I'll show you how to upload and how to visualize the data and analyze. Okay, performance evaluation of proposed framework. So we already have a framework here. This one, I'm going to evaluate the performance. Okay, so by using some metrics, we are going to evaluate the performance of each layer. At infrastructure layer, the cloud and edge computing improves the real-time IoT data processing. You know that edge computing means the processing data at the edge itself or the router or the gateway. Okay. And it will be measured by high throughput and low latency. Okay. The throughput will be high and the latency delay will be low. At DevOps layer, fast and reliable software delivery is ensured by using deployment frequency and build success rate. Okay. So deployment frequency means the frequency of deploying the software, and build the success rates. Okay. The rate of success of building the software by using the tools like Docker and CID, you can make the software development faster. That's what they mentioned. Okay. DevOps layer, developing. Okay. Softwares. Application layer, how the user interacts with the system. Okay. What about the response time? The system respond to the user. Then API throughput, latency to ensure data flow, data processing and output. Okay, how much delay it's take to process the user data and the user getting the output on his screen. Finally, governance layer, System stability is checked using uptime, how long the system is up. Okay, whether it is in between going down or not, the system is reliable or not. Fault tolerance, can it tolerate the faults? Okay. Then recovery time, if it is gone down, how long it will take to recover. Then ensure the system works well under heavy load. Even after you give heavy load, the system will work properly. That's what they are checking in the governance layer. Then challenges of cloud-based digital transformation, security vulnerability. So whenever you are keeping all the data in a centralized cloud platform, private cloud platform, there may be a single point of failure. Recently, some hackers attacked the Apple Cloud server. So all the data kept in the Apple Cloud server gets hacked, and the companies got lots of loss. Okay. They it impacted the company's performance and also economic failure, economic loss. Okay. Then service provider dependency. You want to depend upon internet and the service provider. So if there's an outage, it will make the application. You cannot access the application. Sometimes, Google server gone down means you cannot access service Google Cloud. That's why. That's why we have multiple servers, no concurrent servers. Also, if one server is gone, you can access the server. Okay, that also with the same IP. That's possible. Okay. Then standardization integration challenges. So lack of standardization and makes interoperability, migration between providers and integration with the access system is difficult. Okay. Performance and latency constraints. So cloud may face some latency due to network limits and distance, which affects real-time applications. Sometimes, uploading data to cloud may be taking a lot of time because of network issues. That's why people go behind fog compute. Nowadays, they are going behind fog computing. Okay. Regulatory and compliance challenges means every country will have some data regulations and sovereignty issues across their location. So we need to follow those rules and regulations before making that cloud adopted for the company. Okay. Then implementation. So based on these models, I implemented a project, okay, which integrated cloud computing, DevOps, edge computing using IoT, and along with it, I added AI-based machine learning techniques to develop agriculture crop selection project. Okay, so in this project, what I have done, I have a data set, okay, from Kaggle, which has the values for temperature, humidity, rainfall, pH, soil moisture, soil NPK test, sorry, any nitrogen, phosphorus, and potassium values will be there. It will be sent to a machine learning model, whereas the algorithm we have is random for us, and we will make a model. Okay, for that making the model, we have to train the model by using this data again from data set. Then we will give some sample data and test the model. Okay, then we will give some sample data to predict the outputs. Then we will make the model or export the model, and we will download or import the model. Okay, we will export the model here. Then that model will be imported in Raspberry Pi, where we have connected the actual sensors for temperature reading, humidity reading, rainfall reading, pH reading, NPK reading, then soil moisture. All these values will be read and given to Raspberry Pi. What the Raspberry Pi will do, the Raspberry Pi want to predict the crop, right? So it will forward the values to the model which it has already downloaded from the previous step. Okay. So they will send all data into the model, and the model will predict the output, which is the best crop. Along with that, they will send SMS also to the farmer. Also, they will upload the data into cloud platform. And for this case, we have added cloud platform, SaaS based cloud platform called as ThinkSpeak. We have mobile phone application for sending SMS to video. Then we have machine learning. Then we have which one? AI. We have DevOps. Okay, see here we are using DevOps for automating the code in Raspberry Pi. Okay, that's the new system which integrates all the features like technologies like cloud computing, DevOps, edge computing. Why we call it as edge computing? Because the Raspberry Pi is, machine is a processor which is connected to sensor. It is the one which processes the data. Is at the edge. Okay, along with IoT sensors, and we have IoT AI machine learning techniques also. That's what mentioned here. And the sensors which I told you, temperature, humidity, pH value, nitrogen, potassium, phosphor, they are the values taken from soil NPK tester. Okay. Then the cloud, how do I implement the cloud? I have a website, I have an account in a website called as ThinkSpeak. So I'll show you my ThinkSpeak account. This is a screenshot actually. I'll go to my ThinkSpeak account. This is my ThinkSpeak account, thinkSpeak.mathworks.com. When you go there, okay, I'll go back and show you. I already logged in. Okay, when I go there, I can create 4 channels because I have a free account. Okay, this trial account. So 4 channels. I have many projects here. So I'll go with the second project, which I am discussing now. Revolutionizing agriculture through smart farming by employing advanced machines. So in that, uh, we have uploaded the value of sensors, temperature, humidity, soil moisture, nitrogen, phosphorus, then potassium. You can see the values here. Okay, and you want to down see the value dates also mentioned there. You want to download these values, you can go there and export the values of sensors. That also possible. You can export this thing. Okay, here you can see the values, and now it's a database. Okay, slash SaaS based cloud platform where you can store the data and analyze that. How we analyze? By using these graphs, we can analyze the values given of each sensors in every day and time. Okay.